Hello everyone, I'm Sitao, PhD student at Rugged Business School. I work with Works from Integrated Media Systems Center of Viterbi School of Engineering of USC. I will present our paper, CrowdMap, Spatial Temporal Realization of Anonymous Occupancy Data for Pandemic Response. CrowdMap is a dashboard application. It realizes occupancy data derived from Wi-Fi access points, and it was deployed for 3 USC campuses and 259 buildings with help of USC IT team. It allows users to explore spatial and temporal occupancy patterns of university campuses. It can power campus risk management and related policy decisions in a pandemic such as COVID-19. Now let's introduce our CrowdMap application. Here is the system architecture of our application, which contains 3 components. Presentation layer, which is user interface. Data layer, which contains all the data and the command line interface. Service layer, which provides core functionalities for our backend service. Let's introduce our presentation layer first. The presentation layer is implemented using View, Mapbox, and HighChart. Here is the user interface for our application. First, we go to the login page for users to log in. We use two-factor authentication to ensure that only USC authorized users can log in order for data protection. After logging in, we go to the main page, which contains spatial and temporal information of Wi-Fi connections for USC campus. In the left side, we have a built-in color-plus map to show the spatial hotspot of Wi-Fi connections of USC campus. In the right side, we have a line chart to show the temporal trend of Wi-Fi connections. We use a time slider to connect left-side spatial information and right-side temporal information. It can give user a comprehensive understanding of crowd density of USC campus. We also have a search bar to search for a specific building. The map center will go to the location of the building you searched. When we click on a building, the bottom of this page will show the detailed spatial and temporal Wi-Fi connection information of this building. Similarly, in the left side, we have a floor map which shows the location of each access point on every floor of this building, and we use bubble chart to show the number of connections of each access point. If you hover over the access points, it will show the detailed connection counts. In the right side, we have temporal trends for Wi-Fi connections of every floor of this building and every access point on each floor. And we also use a temp slider to connect the spatial and temporal information. And we can see our application can provide a very detailed information of core density, not only at campus level, but at building level, even floor level. We also have a report page. Here we can see it will show the detailed connection data as tables for different buildings and different time periods. We have a user preference page, which allows users to select different campus, buildings, and time periods which they are interested in. As we can see, if I set different buildings and time period, the main page will show information for only these buildings and time period. After showing our user interface, let's introduce our data and backend services. As we said before, the idea of CrowdMap is we use Wi-Fi connections from access points inside every floor and every building on campus to represent campus occupancy data. So every connection to the access points of every building every day are collected by the USC ITS team to build a network logs file. Code of this file contains device ID, access point this device connects to, connection time, disconnection time, and duration. After we get network logs file, we do the daily and hourly aggregation to get the occupancy count of every access point. And in the service model, we use it to compute occupancy count of every floor and every building. In order to show the spatial pattern of the occupancy count, we also have a GeoJSON file which contains the geolocation information of every building and every access point. After we collect and pre-process all the data we need, we integrate them to our backend services to provide the service for our front-end user interface. We also provide a command line interface which allows system administrator to do the data pre-processing offline, considering large volume of connection data. Now let's talk about our backend services. We have 3 core modules in our backend services. The first module is to compute the occupancy count of every access point, every floor, and every building in a specific time period set by users. Second one is a user preference management module to store user preference of time period and buildings they are interested in. The third one is a report generation module to allow users to see the detailed occupancy data. And we also have a user authentication function to do the user authentication. Our backend is implemented using Node.js, Express.js, and LinkU. Our CrowdMap application can be very useful in many use cases. Firstly, it can help with the campus risk management in the pandemic. For example, through our building map, we can see buildings in a green box have a high degree of crowd density. In our temporal graph, the connection peaks often happens before the time of the midterm and final exam. So in these places and during this time period, there is a high risk of COVID spread. Secondly, it can help with the campus policy making, such as reopening decisions and classes operating options. So currently, most of the universities make classes in person, but we don't know actually how many registered students eventually go to the classrooms. From our application, we can get the accurate number of connections of every classroom during lecture period. So we can give the policymaker an estimation of the proportion of the student who actually go to the classroom. So they can make a better plan for the classes and classroom schedule for the future semesters. So this is the presentation of our paper. Thank you for the listening. Hope you all have a great day.